Hello, excuse me. Excuse me, please. See, actually, your voice is not going in the live stream. Can you please check out and see the comments? Not going. My voice is going, I think. Please see the comments once. Actually, my voice is reachable. Your voice is not going. Your voice is audible only here, but live stream it is not. They are not. It is not reachable. Yeah. Google Meet it is working, but live stream I think it is not going.
Yeah, I am there. Along with me, Subhangam is also there. So, uh, yeah, we can go ahead. Huh? Okay. So, I am just sharing my screen also. Is it visible now? Yeah. So, the basic idea was whether we are able to predict this forest fire for the next day. Suppose today, for tomorrow, for the next day actually. And if at all I am able to predict that fire, forest fire, then what will be the scenario if no action is taken? In how much area it will spread after 1 hour, and what will be the death in another 2 hours, 3 hours, 4 hours, up to 12 hours. So that kind of simulation is required for this particular problem. So if we go, why basically we have chosen this particular idea is this fire, this causes of biodiversity losses, carbon emissions, and many economic damages are also there. It is driven by climate change, deforestation, human activities, and traditional detection systems are very reactive. So once it has happened, then only they are taking it. So they are not predictive. So that's why that action has been taken. So if we talk about the previous statistics on the forest fire, globally around 6.5 plus million hectare of burnt area annually it is going on. In India, around 36,000 fire alerts in 2023. Forest Survey of India is one of the agencies which is providing these alerts. So economic loss is also there. And forest fire monitoring in India, how it is done currently, basically the responsible agency is Forest Survey of India, and they are using the satellite-based alert system using models and SNPP data. That is again predictive. That is not reactive basic, not a predictive one. So there are gaps. Is like alerts are post ignition. They are not predictive. Terrain and spread modeling is minimal. The second part of the problem statement. Weak integration with the alerting system, basically. So now the problem statement it goes like one example I am taking it like Uttarakhand. It causes environmental damage and resource loss. Additional detection is very reactive. This proposal aims to create a predictive model that not only identifies the risk zone but also simulates the potential spread dynamics. So that way need to be done. So the two objectives we have given it over here. Yeah, hello. Use machine learning and deep learning accurate spatial modeling for predicted forest fire, simulate the spread, and develop a modular and scalable modeling pipeline. So if I just go in the detail, the first objective is to prepare a probability map for the fire for the next day. And then second objective will be to simulate the spread of the fire within 1, 2, 3 or around 6 hours from the high probability areas derived in the first objective. So this is the broad methodology goes like this. You have the geospatial feature data set. Then there are some machine learning or deep learning models are there. So this kind of probability map or the prediction map can be created. And once this map is created, it's classified into highly risk zone, low risk zone, moderate risk zone, or no risk zone. Like green area, you are saying they are no risk zone. So this is one raster image for pictorial representation basically over here. Now, once it is done, then I go for some of the areas which are under high fire zone or the high probability zone. So if you can see after 1 hour, what will the spread after 2 hours, 3 hours, up to 6 hours. So what will be the spread? How much it will spread? So one basic methodology is there for the spread modeling. We are calling it as a cellular automata, or you can also use some if any machine learning techniques are there. So that if you can simulate it to that technique also, so that is also well accepted. So the first part is deep learning and machine learning for the prediction map, and the second one is either CA or some other modeling techniques to simulate the spread. Okay, so some of the tentative data set, it can be the burnt area, the vegetation health indicator, surface temperature, precipitation, the weather climatic variables like wind or the relative humidity, elevation, slope, land surface, annual vegetation type map. So these are some of the basic feature types or the feature data set. And the target data set for the first objective, it can be this thermal anomalies, the fire, which is available from the model. So you can take the year from 2017 to 2024 onwards. These are the tentative data set. You can use some other data set as well. So some of the tools that can be used, some of the data set you can get it from Google Earth Engine, from Python libraries you have to use, scikit-learn for like random forest, XGBoost, UNet for the TensorFlow, or you can use some open source GIS software as well, like QGIS or Matplotlib, and GDAL, Rastio, these are for the data handling tools are there. So one again, you can see the same which one I have shown earlier also. This one of the prediction map, and then one if you can see here, I will just run the animation in time domain how it is increasing. So this kind of simulation is a very indicative kind of thing. You have to prepare it in a better way using some machine learning or the CA technique. So these are some of the references and tools. So these are I will just stop my presentation over here now. So this was the. So I hope you understood it. And if anything are there, you can always connect to us, and we will always be happy to help you for the as a mentorship for this particular problem statement. Thank you very much. Over to you, the team Hack to Skill.
Thank you so much, sir, for the explanation. I hope that gives us a better understanding may I request to the other mentors from problem statement to AI-based helpbot? Do we have Utkarsh and Nitish Kumar? I hope that gives us a better understanding. May I request to the other mentors from problem statement to AI-based helpbot? Do we have Utkarsh and Nitish Kumar?
Hello, are you audible?
I hope that gives us a better understanding.
Yes, you are audible.
You're audible.
Hello.
Please go ahead. You're audible, sir. Please go ahead. Hello. May I request Utkarsh, Nitish Kumar, Kaushik, any one of you there? Vamshidhar, sir, can you just check on them?
Yes, I'm checking with them.
Yeah, sure. So meanwhile, we'll move to the problem statement 3.
Yes, we'll move to problem statement 3.
Sure. So we'll discuss and we'll circle back on problem statement 2 again. But let's discuss problem statement 3, monitoring air pollution from space by an integrated approach using satellite observations, ground-based measurement, reanalyzing data, and AI and ML techniques. May I request Dr. S. Suresh Babu.
Yes, myself Sujit here. Can I share the screen? Yeah. Yeah, this problem under Bharatiya Antariksh Hackathon 2025 is basically to monitor the air pollution from space through an integrated approach using satellite observations and AML techniques. So we know air pollution is one of the major problems which we are facing now, and it is of course an increasing problem nowadays, not only here in India but all over the globe in many of the cities. So there are different ways to, we are using different types of ground-based instrumentations for monitoring the air pollutants in the atmosphere. And as we know, there are different types of air pollutants in the atmosphere, and one of them is particles in the atmosphere, which we call particulate matter. And based on their size range, we generally classify them into different categories: PM1, PM2.5, PM4, and PM10. And these size range of these particles which are there in the atmosphere is in such a way that they very effectively interact with the radiations, both solar radiation which is incoming and the terrestrial radiation which is going out. So since they have very effective interactions with the solar radiation, with the abundance and characteristics of the aerosols or these particles in the atmosphere, the backscatter radiation which is going back to the space will be varied. So if we can establish a relationship between the radiation which is reaching the top of the atmosphere or which is measured by the satellite and the abundance and characteristics of the aerosols or the particles which is in the atmosphere, then we can make use of the space-based or satellite-based monitoring for the observations for monitoring the air pollution. So that is the idea behind this problem, and the specific problem or the objective of this problem is estimation of particulate matter concentration using the radiance measurements from INSAT 3D series of satellites. So we have INSAT 3D satellite observations, INSAT 3DR observations, and 3DS observations. So using the visible radiance from these INSAT series of satellites, we can estimate the concentration of particulate matter in the atmosphere. So this is the methodology which can be followed for the estimation of PM concentration from the satellite measurements. So we have satellite-based radiance measurements in the visible channel, and then we have to have the surface-based concentrations of particulate matter. So we can make use of the surface-based observations from network of observatories like CPCB, Central Pollution Control Board, or such kind of observations. But then when we are trying to establish a relationship between the satellite-based radiance and the surface concentration of pollutants, the problem is what satellite is measuring here is the columnar effect of the particles. But what we have to have is the surface concentration of the particles. So when we are trying to get the surface concentration from columnar measurement, we need to have information about the vertical distribution of these particles and also the atmospheric boundary layer characteristics. So you can go for the atmospheric boundary layer characteristics from different sources like reanalysis data. So using the satellite-based radiance, then surface-based PM concentration, and atmospheric boundary layer parameters from different sources like reanalysis, we can train the AML models. So once this model is trained, so you can use different approaches like random forest approach to train the model. So once you have the trained AML model, then you can use this model and take the satellite-based radiance in the visible wavelength as the input and then get the PM concentration map over the Indian region. So this methodology can be followed to generate a PM concentration map over Indian region from satellite measurements at a spatial resolution of kind of 1 degree by 1 degree. So these are the data sources which are available to address this problem. We can have the radiance data from INSAT 3D series of satellites from ISRO MOSDAT website. And PM concentration from different ground-based network of observatories can be obtained, and one is CPCB. And boundary layer parameters can be used from different reanalysis data sets like MERA2. Or otherwise, MOES data set is also can be used. Any of the reanalysis data which gives information about the atmospheric boundary layers, including the PBLH height. And this is the work plan which can be followed. So you have the satellite-based radiance data in the visible wavelength, and first it has to be converted into reflectance. And of course, we know we can do this retrieval only over the clear sky pixels. So you have to follow different methods for cloud scanning. There are different cloud scanning methods available even for INSAT 3D cloud scannings. And after the cloud scanning, we have the clear sky pixels. Then over these clear sky pixels, we can convert the radiance into reflectance. And using the radiance, which is converted into reflectance now, and surface-based measurements and boundary layer parameters, we can train the AML model. And now using this AML model, we can take the radiance data again from the satellites and we can generate the PM concentration maps over India, whether PM 2.5 or PM 10 concentrations. Once these maps are generated, then we can use the ground-based measurements of particulate matter concentrations to validate these retrievals. So the final outcome of the problem is spatial map of particulate matter concentration over India, PM 2.5 and PM 10 concentration maps over Indian region, and a spatial resolution of kind of 1 degree by 1 degree. So this is the problem which can be addressed to monitor the air pollution from space-based technologies.
Thank you so much. Can you hear me?
Yes.
Okay. Thank you so much for the briefing. Can you? Okay. Let me share my screen again. Okay, so we've talked about the problem statement 1. We've talked about the problem statement 3. Let's quickly move to problem statement 4. So the second one we'll discuss probably at the end again. So Neil and Sean and Siddharth, if you guys are there.
Hi team, am I audible?
Yes, you are. So that's the four.
Yeah, I would like to share my screen.
Yeah, go ahead.
Yeah. I hope the screen is also visible.
Yes, it is.
Yeah.
Please go ahead.
So this is regarding the problem statement 4. It's the title of the problem statement is designing of chain of thought based LLM system for solving complex spatial analysis tasks through intelligent geoprocessing orchestration. Now, when we talk about standard GIS workflows, they mainly require a lot of domain expertise to generate some maps. On the left, what we can see here is a flood hazard or a flood vulnerability index map that has been generated through a lot of domain expertise. And a standard GIS user, what he would do is he would create some sort of a workflow like this on GIS softwares like ArcGIS or QGIS. Now, what this challenge basically is asking the participants to do is, can we actually generate these kind of workflows through some natural language queries? All right. So in this challenge, basically there are four major objectives. The first one is basically they have to develop a reasoning enabled framework that combines LLM and geoprocessing APIs to automate these basically multi-step geoprocessing workflows from natural language. So it is not a simple LLM-based interface. The LLM should also reason and understand based on the workflow. Like if I'm asking the LLM to generate a flood vulnerability map, so what are the inputs that are required to generate those vulnerability maps? And once you have those inputs, then what steps that are to be followed to generate those sort of vulnerability map? Then the next thing is basically how to integrate data from heterogeneous sources, be it either through libraries or through tools or the resource selection. Then we'll have the participants would actually need to build a user interface where basically they can communicate to the LLM through a chatbot based mechanism, and the results would be displayed in the map based interface. And finally, the users would also have to demonstrate these tasks, uh, either be it flood mapping or site selection using input-output matrix validations. So this is basically, these are the
Prashit, can you just mute Anish Nile? The mic is muted now. Nile, can you hear us?
yeah. Now is it clear?
Yes, it is audible.
Okay. Good. So did I miss what was my
Just one
voice not
slide
audible?
before, if you can continue from the previous slide.
Okay, okay. So these are the basic objectives. Like I've already mentioned, the first objective is basically to develop a reasoning-based framework where the users would actually have to develop an interface so that they can interact with the LLM models. And these models are not a simple interface where they can fetch the data and display the output. They should actually be able to reason through some chain of thought process and link the workflows together and prepare a geospatial workflow so that, say, for example, generating a flood vulnerability index map, their user needs some information on past flood events. They also need information on slopes. They also need information on the land use, land cover, and how frequently the flood is occurring over all these places. So all those inputs, how they link, combine to generate those outputs is a major task here. They have to build an interface so that the users can communicate to these LLM models, and they have to demonstrate these the interface capability through some special task that would be given on the day of basically the judgment. So the problem statement on the day, basically the task that has to be carried out would be a special task. How well the model performs, that day we'll be judging them using that query. Next is basically how you can actually display these outputs. So these are something like an expected outputs, wherein you'll have to either display a web-based interface or a desktop-based application. So you can go for a QGIS-based approach also, where you can develop a plugin on QGIS, or you can develop a web-based interface. You can remember a terminology here that is called as RAG agents, where an LLM basically communicates to the database or the documentation that has been provided, and derives out insights from that and gives you the output. So there's a simple interface that you can see here on the right. On the Here you can see the map that is being prepared, but when I'm telling the LLM to generate a flood hazard map, it is actually thinking for some time. It is telling that what are the informations that I have to collect, and then it will do some analysis like collecting less, then it will do some analysis like analyzing, creating those workflows, and then the displaying the output. So all those things have to be combined and displayed here. And when you talk about the data set and the suggested tools and technologies that are required, all the data set, whatever you need, will be available in open source domain. One of the popular data sets that you can use is satellite images from Bhunidhi platform. Another is if you are looking for some vector data set, you can use some open series data set like OpenStreetMap. You can basically get it from many of the service providers. One of them is geofabric.de. And when we are talking about the suggested tools and technologies to use, you can go for open source geoprocessing tools like QGIS, GrassGIS. You can look for GDAL APIs, or you can look for APIs from Google Earth Engine. So those are also very good documentation too. Then you can look for open models like open LLM models like Llama, Mistral, Phi2 for performing these tasks. So this is like a basic proposed methodology framework. Users, the participants can develop various agents. First agent would be something like a satellite image gatherer agent. So that would be like a data reader, where you can fetch data from various stack APIs. Then you can also fetch data from your local GIS database, or you can bring your own satellite image and upload it. Then you should have a chain of thought reasoning model, which would synchronize between the data reader, the geoprocessing libraries, and the map rendering APIs through an interactive visualization framework, where you can either visualize the data through map or generate some statistics through the chat window. Graph plotting, you'll get bonus points if you are able to do some sort of graph plotting. You definitely need some sort of a knowledge base to point your model to. So you will have some API documentation, geoprocessing APIs from PyQGIS, GDAL, or equivalent, something like a Google Earth Engine would be helpful. So these are some references that you can take forward. You can take forward the PyQGIS documentation and the Google Earth Engine documentation for basically pointing your models to generate those chain of thoughts and retrieval augmentation generation agents. So that's all from my side. These are basically some of the evaluation parameters that we'll look into. Mainly what we are looking forward is how well these models, if I'm say giving you a problem of flood vulnerability mapping, then probably how well does it perform for site suitability mapping. So that sort of a trick question may come probably to evaluate the robustness of your framework. So that is all from my side. Thank you.
Thank you so much also for that quick briefing. So just before we go ahead and for the problem statement number 5, may I request if we have mentors from the second problem statement, AI-based helpbot for information retrieval.
Yeah. So whether my screen is visible?
Yes, we can hear, see it. Yes, yes.
Okay. Okay. So this is the problem statement number 2, and that talks about AI-based helpbot for information retrieval from a website. Actually, this is basically expects you to carry out extraction of all sort of information, be it static or dynamic, that is present at a particular website. And when we talk about web address, we are precisely talking about MOSDEC, that is www.mosdec.gov.in. This particular portal is basically for the satellite data archival, dissemination, and all sorts of services in terms of geoportals or geoservices or APIs. So all such information it is available freely to the citizens, and it contains a lot of information, including FAQs, the documentation that is related to the satellite data products, their ATPT documents, different sort of retrieval algorithm that is used to generate the different sort of satellite data products, and further the other kind of support materials, be it softwares related to the data reading that supports users of satellite data in terms of reading the data, how to utilize that particular satellite data, and what are the different sort of applications. So this all information is available at this particular website. So what we expect as a solution to this particular problem statement is to have a AI-based helpbot that can scan and process all the available information, irrespective of the label it is hidden in, or the inside any of the navigation menu or any of the page, be it a static in terms of a PDF document or some text that is written over the web page, as well as the kind of images in terms of alternate tags that is attached, meta tags that are used in all these pages, or other sort of information that is hidden at multi-level navigation or deep within the different sort of pages or information hierarchy. So this particular solution will be able to scan the all the information, will create a knowledge graph of over this information, and will help the users to resolve their queries in a conversational mode. Though the specific objectives, if we talk about for this particular statement, I would request Nitisha to continue with the explaining the objectives.
As Mr. Utkarsh told that we have to develop a AI-based chatbot. Let me tell you about MOSDEC. MOSDEC is a web portal for our data center, and it hosts data from multiple meteorological and oceanographic satellites. We can take example of like INSET series of satellite, which is our meteorological payloads. So let's say we have different satellite INSET 3D, 3DR, and 3DS. So these data were hosted on MOSDEC, and from these satellite data, we used to derive lot of products, which we give the different product levels to them, say level 1, level 2, level 3, like that. So the objective of this chatbot is to leverage the natural language processing and machine learning techniques to understand the user queries. The sample user queries, you can say that a user can ask what is the difference between INSET 3D and 3DS. So you have to, the chatbot has to do mining of data and relationship across the website, the data hosted on website. The second example that we can take is the data is derived on different extent over the 1/3 of the coverage area, that satellite used to acquire. So user can ask the geospatial extent of the particular product that is hosted on MOSDEC. So that also the AI chatbot is able to answer the queries. The third one is it should aware it should answer the context aware questions. So like what are the different data format that is available on MOSDEC, mosdec.gov.in. That kind of questions the AI chatbot should answer. The one of the most important functionality that that AI chatbot should give is modularity. If the solution fits, and if this solution will go at some level, then we would like to extend this solution to other problems also. So the modularity is also important. The next one is the expected outcome. So the expected outcome through this problem is an AI-based intelligent virtual assistant that can answer queries in conversational mode. So it is like you can say that it is just like chat GPT kind of user interface where a user can put his queries and give the prompts, and that your AI chatbot should answer those prompts. Now, let's come to the next point is the data set required. So the data set required is documents, static content, web pages, tables, metadata tags, area labels, those things which are hosted on mosdeq.gov.in. Since mosdeq.gov.in is a web portal for a data center, it contains a lot of documents which is in format of .doc, .odt, .pdf, .txt, all those kind of formats are there. And the information is also present in the web pages. So the team has to scrape the content from the web pages, take the content of the hosted document, which is in different formats, as I told, and go through the information inside those documents and web pages, and uh, train your AI chatbot for answering the prompts. The suggested tools and technology that we have written is you can use retrieval augmented generation, then you can utilize LLM, then you can use spatial, then you can utilize NLTK, then you can utilize dialog flow, you can also use node.js, Rasa, etc. There is no limit. You can utilize the technology in which you are comfortable. The next one is expected solutions and step to follow to achieve the objective. So the team has to gather the structured and unstructured data, which is hosted on Mosdeq. So the structured and unstructured data like product catalog, documentations, fact data, then articles, all those things, the team should pick up those data. Then you have to choose an appropriate model for your AI chatbot. Then you have to pick up a appropriate front end. Then you have to train your model with the data that you have collected, and you have to integrate your front end with your backend model. Now comes to the evaluation parameters. So the next is evaluation parameter. The evaluation parameter are intent recognition accuracy, the entity recognition accuracy, then response completeness, and response consistency. So these are the four basic parameters that we are going to use to evaluate the AI chatbot. And if team proposes some more matrices to evaluate the AI chatbot, then that is also welcome. Team can use other matrices also for evaluation. We are open for that. So that's it with our problem presentation. Thank you.
Thank you so much. So before we move forward, may I request you to kindly stop sharing your screen so we can just go ahead. So the next problem statement, I hope you're not going too fast, you're in depth. So this video will also be recorded and part of the resource section onto your participation dashboard. If you've already registered, if not, then do register, do check out the website today itself. So coming up next is the problem statement 5, chase the cloud, leveraging diffusion models for cloud motion prediction using ISAT 3DR, 3DS imagery. And may I request Ms. Rosalie or Dr. Abhay to kindly take this forward.
Yes. Am I audible?
Yes,
Hello?
yes, you're
I'll be sharing my screen. Okay.
sure. Go ahead.
Hopefully my screen is visible.
Yes, it is. Go ahead, sir.
Okay. So welcome once again. So I'll be explaining about the problem statement of number 5, which entitled Chase the Cloud, leveraging diffusion models for cloud motion prediction using INSAT 3DR and 3DS imageries. So basically, I'll be breaking down the explanation of this problem statement into two topics. The first one is about explaining why we choose diffusion model in the first place, and second part will be why we have chosen to apply it on INSAT 3DR imageries. So let me come to the first part. So the first part is why specifically diffusion models. So basically, we are working on a set of problems called spatial temporal prediction learning, whereby it is a basic computer vision problem only. It resembles a lot, almost 99.9% with all the video prediction models, which you can find in the research papers. So this one also falls under the same category. Now, why diffusion models? Basically, nowadays, as we are all aware, GAN models are very popular. And GAN models, somehow we can say reach a threshold, or maybe we can say the end of its life, because so far, whatever we can do with GAN models, we have explored a lot of things. But recently, diffusion models have come into the picture, and recent research papers, publications has mentioned that they have beaten GAN models in image synthesis and a generative model synthesis. So this set of problems kind of make it interesting models that can be used and can be utilized for satellite imageries as well. So we want to explore and leverage this power of diffusion models to synthesize new images by predicting on the future satellite images based on condition on the past satellite imageries. That is what the whole problem statement is all about. Now, why we want to apply it on cloud motion prediction, or specifically why do we want to apply it in INSAT 3DR, 3DS imageries? So actually, we are also working on a lot of nowcasting problems. For example, we are working on lightning prediction problems. We are working on thunderstorm problems, thunderstorm prediction problems. But all of those problems, if you want to use satellite imageries, we want to have them at real time. So you need, for example, to predict next 1 hour. We want at the moment, present time, the recent satellite images. However, often at times, because of certain complexities or certain we can say a lot of other problems are there, which we are unable to get those real-time images. So this application of this cloud diffusion models to predict future satellite images can help us synthesize those real-time images, which we can use as a baseline to predict or to nowcast other things. For example, we can use that synthesized image for nowcasting maybe lightning, or nowcasting thunderstorm, or many other problems. We can use that synthesized satellite imageries. So that is all about how we can break down the two. First, why diffusion models, and why are we applying on INSAT 3DR, 3DS, and why basically we're tracking cloud motion in the first place. Now, the objective is very simple. So to say, all I have to do is generate or maybe develop this generative model, or create a diffusion network, which we can use past satellite imageries, which I'll be explaining using the imageries here. So basically what we have is past sequence of imageries stacked together, which are taken in different time frame. So when we stack them together, and all we have to do is now condition or create a diffusion model, or add noise to the next future frame, and condition on a past frame to generate future frames. That is all the problem statement is all about. It's a classical spatial temporal predictive learning. All we need to do is condition our noise on the past frames and generate future frames. That is all about the problem statement to make it short. Now, coming to the data requirement, we are going to use purely in satellite images, and which we can download easily from Mosaic website. And we are going to use multi-channel imageries here, which will be with the visible imageries, the short-wave infrared imageries, and the thermal infrared imageries, as well as a water vapor channel, which we are going to stack them all together. And the temporal resolution of all these bands are all inside 3DR, and 3DS itself is around 30 minutes. And we are going to have a spatial resolution of roughly about 4 kilometers, which we can reduce to 10 kilometers just for the proof of concept. And then we are like open for any other frameworks. We are open for PyTorch, TensorFlow, and like any other condition which we want to use. If we want to use DTPM for the sampling, we can use, which stands for denoising diffusion probabilistic model, or we can use a DDIM. Or in case if we are much more comfortable in creating latent diffusion models, that also we can explore in order to solve this problem. And the expected solution is basically what we are expecting is basically stacking last 3 hours, which basically means stacking 6 frames. And we want to predict a minimum of 2 frames, which is 1 hour ahead, which at the moment we have the lag or the latency of 1 hour. So we want to like get a solution to predict at least 1 hour. And beyond that 1 hour, if you can do, that is much more beneficial. And then we can go up to 6-7 hours, like depending on the problems on the solution, how far it's visible and how the metrics are being calculated and produced. Accordingly, we can see on that. But bare minimum is 2 frames, which is 1 hour ahead. And basically, I'll come to the valuation parameters. Basically, we have all these metrics which basically we use in the computer vision problems for like denoising and all those other aspects. For example, like the prediction accuracy, we have to use structure similarity index, the higher the better, the mean absolute error, the peak signal to noise ratio, as well as we want to have a GI solution where we can use any web-based solution in order to input whatever satellite imageries and predict the future satellite imageries, and as well as show us like what are the metrics based on those like input data which we have given. So that's all about like this problem statement. Hope everything is clear. Like if anybody has doubt, they can look into this picture, and this picture will explain almost the entire concept about the problem statement. Thank you. Hello.
Sure. Thank you so much, Ross, for the brief explanation. It gives a lot of insights onto the problem statement. But yeah, makes more things clear for people to actually pick up that problem statement and start solving the problem. Thank you so much for the quick brief. May I request for the next problem statement, which is problem statement number 6, AI/ML-driven automated feature detection and change analysis of glaciers, lakes, road networks, and urban drainage system from multi-source satellite imagery. For that, we have multiple mentors to join in. May I request Saksham, Abhinav, Santoshi. Anyone?
Yeah, am I audible?
Yes, you are.
Yeah, thank you. So yeah, welcome to all the viewers. We are from NRSC, and I'll be demonstrating the problem statement number 6, AI/ML driven automated feature detection and change analysis of glacial lake, road networks, and urban drainage systems. Here, if you will see, there are 3 features here identified, and the problem statement can be tackled by considering or by taking only one features at this moment. So you will be evaluated based on any one of the features you select based on your liking. So I'll be presenting on the feature, which is the glacial lakes, and my colleague will be presenting on the other 2. So the problem here is, if you understand that we humans, we are emitting greenhouse gases through anthropogenic greenhouse gases, and then it is leading to the rise in temperature, global warming, and then rise in temperature is leading to the retreat of glaciers, and glaciers are melting, leading to the expansion and formation of new glacial lakes. And now these new glacial lakes, which are situated in Indian Himalayas, are possessing a significant risk to the downstream communities in form of a glacial lake outburst flood. So whenever a flood happens or a Gulf event happens, everything which gets washed away in its way. whether it is a road network or hydroelectric power stations or any settlements or people staying there, everything gets washed away and devastating effects can be seen, and a huge implications in the infrastructure as well as economic losses. So if we remind, we have a 2013 Kedarnath Glof event, as well as in 2013 we had a South Lona glacial lake outburst flood event. So keeping this in mind, this is very important topic now, and we need to develop some automatic method or AI/ML model which are capable of automatically detecting and delineating these glacial lakes which are situated in Indian Himalayas. Also, to let you know that recently Indian government, also led by NDMA, they have also launched a glof risk mitigation program itself. So yeah, this is the need of an hour, and this will be a very interesting topic to look into. So the objective here is to develop an AI/ML model for automated detection and delineation of glacial lakes utilizing multi-source satellite imagery, and then we need to accurately classify the lake boundaries. And there are various challenges also with respect to optical data as well as the SAR data, where a glacial lake is sometimes covered with shadow, which can be partial or fully cloud cover, and then glacial lakes are sometimes covered with snow or partial ice or fully frozen lakes. So yeah, it makes the delineation of these glacial lakes a bit tricky. And then third objective is we need to track the multi-temporal changes in glacial lakes in order to analyze how these glacial lakes are evolving in time over time, and we can see and look back after in last 4 decades how they have increased in its size. So the expected outcomes here is to generate the polygon shapefiles of delineated glacial lakes, or whenever there is a satellite pass. And if you see an imagery here, the top figure is imagery of Indian Himalayan region taken from ResourceSat to List4 satellite data, where you see various glacial lakes situated here, where you can see the pixels, blue pixels, and then in the below figure, these are the delineated glacial lakes and overlaid with the glacial lake polygon. So second objective here is we need to identify these, if possible, the new glacial lakes which are getting formed, and how these glacial lakes area is changing over time. And then third, we will try to classify its accuracy by using the reference layers inventories of what we have prepared of NRSC glacial lake inventory. So relevant data, if you like to see the satellite data which you will be using, is the Sentinel-1A, 1B, which is the SAR data, Sentinel-2A, 2B, which is the optical data at 10-meter resolution, and Landsat entire repository of 5, 7, 8, and 9 at 30-meter spatial resolution. And this entire data is available for last 40 years from 1984 onwards, and you can access it through Google Earth Engine. And then we will be giving you a existing glacial lake inventory, so you need not search for where the glacial lakes are. You can just directly you will have some background information. So we will provide you the glacial lake inventories, and over that you can build your model and train it and then test it. And then and temporarily using satellite data, we can try to delineate these glacial lakes. So these are the suggested tools. I think everyone is you are seeing this many times in these slides, and I think you all are aware of this. So you can do it as per your liking, your libraries, and the platform which you would like to use. And then I'll just briefly go over to the steps which you should be following. First is you need to collect the data collection and the preparation, where all the data which I have just mentioned is available in Google Earth Engine, and I'll be providing with you the glacial lake inventory also. Then you need to train your model and then try to delineate the glacial lake boundary. Apply your model to the multi-temporal lake monitoring, where you will detect the glacial lakes in its formation, expansion, and whether they have appeared or disappeared, and how the glacial lake area is changing over time. Then you will convert this as a post-processing step into a shapefile or in a vector format, and then we'll do the accuracy assessment, where few glacial lakes will be selected using stratified random sampling approach, and then the polygon level validation will be carried out using the existing inventory or through the manual delineation. And then this we would like to have a visualization dashboard where the results can be visualized in the GE or any type of a dashboard you wish to show us. Yeah. And then that's the same thing of evaluation. How we will try to evaluate is using the polygon wise accuracy, and how it is you are able to and what's the ability of the model to detect the lakes under various conditions. I'll hand over to my colleague Santoshi. She will be demonstrating the other two features. Thank you.
Hello everyone, this is Santoshi. Me and Abhinav, we are both mentors for this second sub-problem of the problem statement, road racer, unlocking national highway central lines from list 4 imagery. So mainly the objectives of this problem statement are to automatically extract center lines of national highways from the high resolution satellite data of list 4 sensor. And the main challenge includes handling complex challenges such as varying road widths from 10 meters to 30 meters, 60 meters, different widths, and under shadow conditions, occlusions where there is a terrain variation, and because where the road is of 10 meters, we have an image resolution limitation in such conditions as well. And the goal is to create a solution that is scalable and generalizable across different geographical areas of India, and to enhance the automation of road network mapping for better urban planning, infrastructure management, and geospatial analysis. Now, at the top left corner, we see the input scene, which is a list for data. And for this, as reference, you need to take a national highway shape files from OpenStreetMap or any other open source data, and then take a light like buffer on either side which is not less than 30 meters of the road, and then clip out so that other non-road related features, they get removed. And then take this as input, and you need to bring out the center line of the road, not the center line of the clipped image, but the actual center line of the road feature that is visible here. And then ultimately you need to overlay it on the list 4 scene like this. So the expected outcomes for this problem statement include an image processing algorithm or machine learning model, which is capable of extracting smooth and continuous road center lines from list 4 satellite images, a pipeline or tool that processes raw satellite imagery and outputs geospatial vector data in the format of shapefile or GeoJSON, which represents the highway center lines. And then a visualization interface. This is an optional thing for you, where you have to overlay the extracted center lines on imagery for validation. Otherwise, you can use open source tools such as QGIS for visualization. And then finally, you need to provide the documentation and code base, which is ready for scaling across different regions with minimal manual intervention. So for this, the relevant data includes list 4 imagery, which is a 5.8 meters resolution multispectral satellite data sets. And these can be downloaded from Bhunidhi website of NRSE. And then for the national highway shapefiles for reference can be downloaded from OpenStreetMap or any other open sources available on the internet. And then for the problem, the suggested tools and technologies include geospatial data processing libraries and machine learning frameworks and other image processing tools such as OpenCV or Scikit image libraries. And then for the dashboard, Streamlit or Dash libraries can be used, and any other open source tools and technologies can be used. Briefly, the steps to be followed for achieving the objectives include data collection and preparation from the sources mentioned earlier, and then you need to develop your models by designing and training segmentation or graph-based models or traditional image processing methods, or you can have a hybrid model which combines these two, and then use them to detect roads and extract center lines. Then do the post-processing where you apply morphological operations or skeletonization to refine and smooth the extracted center lines. And then the vectorization and export, that is to convert the refined center lines into vector formats. And then visualization and validation by overlaying the results on satellite data. And then evaluation, where your model performance would be evaluated using various metrics, and you can fine-tune your models accordingly based on the results. Ultimately, you prepare the solution for scalable deployment across larger geographies or additional data sets. So the evaluation would be by looking at the geospatial alignment of your road center lines derived with the actual road geometry and how complete and correct they are. We will also look at the visual matching of the predicted center lines to detect the discontinuities or misalignments, and the computational efficiency, where we'll be tracking the runtime and memory usage, especially for large-scale inference over extended highway segments. And ultimately, the test data sets will be shared during the grand finale for evaluation. Coming to the third part, stream tracer, delineating stream center lines from list 4 imagery. This is very much in line with the problem statement B, where you had to extract the roads from national highways. This is extracting the stream center lines from list 4 in the urban setup. So the objective is to extract center lines of streams for urban areas from list 4 data. And the challenge is to handle varying stream widths, shadows, connectivity occlusions, terrain variation, and image resolution limitations. Goal is to create a solution that is scalable and generalized across India. And then to enhance this will be used to enhance the automation of stream network mapping. Again, the expected outcomes at the top left corner, you can see the list4 input list4 image, and the bottom right, you can see the yellow colored stream center lines which are overlaid on the list4 data. So in line with the earlier sub-problem, you need to come up with an image processing algorithm or machine learning model to extract the smooth and continuous stream center lines from list4 datasets. Similar way, pipeline or tool to process satellite imagery and bring out the geospatial vector data, and visualization interface, as well as documentation and code base. Again, relevant data for this includes, along with the list4 imagery, DEM data will also be shared with you, and the stream shape files, they can be downloaded from OpenStreetMap or any other open source for reference. Suggested tools and technologies, same as the earlier sub-problem, and you will be evaluated in similar lines for geospatial alignment between the center lines of the predicted and the reference ones, and for completeness and correctness by visual inspection, and also the computational efficiency. For this as well, test datasets will be shared during the grand finale for evaluation. Thank you. Over to Hack to Skill. Out of these three sub-problems, only one sub-problem has to be selected for the final solution.
Sure, that gives a lot of understanding about the problem statement, what is to be picked up, particularly solved on a participant perspective. Thank you so much for putting a lot of thoughts and briefing out the problem statement for us. I hope the participants have a lot of understanding now about that problem statement. But taking the reins forward from here onwards, last problem statement for the day. So for that, I would request Mr. Alok and Jibin to join us to give that understanding. The problem statement that we are going to discuss is developing algorithm for air quality visualizer and forecast app to generate granular, real-time, and predictive air quality information, especially in smaller cities or rural areas.
Yeah, I'm Alok. Am I audible?
Yes, you are, Alok.
Yeah, can I share my screen?
Go ahead. Yes.
Okay, sure. Yeah, is it visible?
It's visible. Go ahead.
Yeah. So this problem is about basically creating a mobile application that will provide the air quality forecast especially for the rural areas. Basically, the problem is currently we have a lot of air quality forecast and visualizers, but they provide data for major metropolitan cities. And smaller rural areas or nearby areas of the metropolitan city, we don't get that kind of accuracy in the forecasting of the data. So that data gap we want to bridge using this problem. So this is the basic underline basically. Predictive insight, we will be emphasizing on the predictive insights for the rural areas for this. This is the basic core issue is that only, like we are not able to get the granularity of the data in the smaller cities. So current limitations also exist for that only, because we are getting all the data and AQI applications and APIs, and basically IMD data itself is also available for the major cities also only. Yeah, so the objective of this application will be to majorly 5 points will be there, like real-time AQI display. This is all the fundamentals will be for the rural cities only. We can use the data of the large metropolitan cities, but we need to have the predictive analysis for the rural cities itself. So for an historical trends visualization also we will be showing for this. Forecasting till 24 to 72 hours based on the our incorporated meteorological data. So dataset I will be providing basically for IMDs and CPCV dataset we can use here. Satellite data also we can use here, but there is another problem statement that is using the satellite data. So we don't want to intersect that. That should be fine, I guess. And the major 2 points will be here, like pollution source mapping and the health recommendations based on the pollution level of those cities. Yeah, so expected outcome will be like real-time data, forecasting for that, and the AQI heat maps that we'll be using, and the push alerts. Basically, if there is the threshold that will be decided by the models, and after that, there should be the Firebase-based alerts. That's why it is a like mobile application, so that we can send the Firebase-based alert for this only. Yeah. Yeah, so data sets are this. I will be going through the data sets basically. Primarily, we will be using our ISRO satellite data set, CPCB and IMD. So I'll just show you the data set as well. So this is the Kaggle data set. Here you can see the historical data set we can find from here, 2015 to 2019. This is again with the major cities, but this provides the data set for the 19 cities for us. So we can take help of this. Here, this provides the energy emissions as well. So urban emissions are there. This provides the energy. So this will be helpful for our mapping the pollution sources on a certain amount. So the average summary of the air quality and monitoring is from the last, I think, 8 to 9 years data. It will be showing here. And there is ODC data portal also. Here we can get the CSV files of all the data, or the APIs if we want. API also we can get using this. Yeah, so suggested tools and tech. Yeah. So for because this will be a mobile application, so UI and framework we can use either React Native or Flutter anyway. If we want to have the cross-platform, this is entirely on the participants, whatever they want to use. I would suggest to use the Flutter to have it the cross-platform application. And backend architecture for this, because we are going to integrate the Firebase notifications based on the threshold, so we can have the Google Firebase as well. And Supabase DB we want to use because the time series data model, because it is going to be the predictive analysis for next 24 hours. So we can have the time series predictive model. I would suggest ARIMA model need to be used for this. And APIs for that one, IMD also provides the API data that we can use, or the CPCB data also we can use for that. And for maps visualization, Google Map or ISRO itself has a Bowen Map application. So either can be used. This is entirely up to participants. Forecasting model for this itself, if we want to have, we can run the training data sets on the TensorFlow Lite. But for the predictive analysis, again, we want to use the, because it is the time series itself, so ARIMA model we can use for this. And for the analytics basis, we can use either of that, Firebase or Google. Yeah, so this was the brief for this. Yeah. Thank you.
Yeah, thanks a lot. Thanks a lot, Look. So that gives us a basic understanding and the overall gist about that problem statement. But thank you so much to all the mentors for briefing out these top 7 problem statements for the Bharatiya Antariksh Hackathon 2025. We're truly excited. I hope the participants who are viewing this or people who will join us later to the stage will also get to know more about these problem statements and what thoughts are coming back from, what are the right expectations now in terms of building out the solution bit of it. But I'll take not more time. We're already running out of time. So what I'll do is I'll take 5 more minutes just to walk everybody through the platform and how that work. For people who are new about this hackathon, who are looking at this session for the first time, people who have already registered might have the basic understanding of how the platform works, how the website works. So that's the website that you're looking at, is the Bharatiya Antariksh Hackathon 2025 webpage. So if you scroll down from here, you'll find all the details, the why to participate, challenges, schedules, rewards, and FAQs as well. So I'll not read through everything that's there on the screen, but you can definitely, explore more on the challenges bit of it. These top 7 challenges have already been discussed. Remaining 7 challenges will be discussed in a call tomorrow with another set of mentors who will be joining us tomorrow as well. So we'll discuss from problem statement number 8 to 14. But having said that, this is the brief timeline as well, which has been put across on the web page. You can just have a look. What is going to happen? What are the different milestones of this journey of your hackathon? What is the right expectations? What are the rewards? What are the benefits? And also, I like to call this out real quick is, if you're a participant and if you haven't joined in Discord yet, please do make sure you joined in Discord. We will be communicating the mentor-mentee sessions. We will be communicating. We will be, the mentors will be joining in Discord as well in order to facilitate any questions that you may have, and we'll engage on Discord as a platform. So the invites and everything will be rolled out at the right time to you. So before doing that, make sure you join the Discord and have an idea of yours with them. Make sure your team join in. I saw a lot of questions on the YouTube I'd like to address for the masses is, yes, there's a hard and fast restriction of having 3 members in your team and maximum 4. Make sure you're using the same template that we have sent across in order to submit your ideas to us, right? So once you register for this hackathon, this button turns into a dashboard. So if you go to the dashboard itself, so that's how your dashboard will look like. This is a personalized dashboard, so you can have a look at that. So the team management is right here from where you can actually start building a team, right? So you can create a team, or you can actually look at the explore public teams if people are accepting any invites there. So you can look at that aspect of it. But in terms of submission, here's your template which you need to download. So all of the information, everything about your idea should be filled in this template. It is mandatory to use the same template in order to make consistency across all participants. So make sure you download this template and do not come up with any other template of your own or any other format. So we have made it very clear that one needs to follow this template in order to provide a solution to it. There are questions that needs to be answered while you're submitting your ideas. So make sure you drafted everything. You upload the deck once it is ready. You upload the PPT, convert into a PDF and upload it here. Make sure you hit the submit button right here, and then rest assured, sit back, relax, and then wait for us to make the announcement for the top teams. Right? That's what it is. And in terms of the resources, we'll also host this particular session in resources as well. If you want to refer it back again to and fro, you can go ahead, do that at any time. So by tomorrow, you should be looking at this video or this session to be hosted under the resource section. So that's about it. If you again want to look at the challenges, here are the challenges listed right here. So you can just have a look at them. But broadly, these are the key highlights. So team management submission is the particular things that you got to look at. But apart from that, we truly are excited to see your solutions coming to us. I thank each and every mentor joining us today for the problem statement explainer session. Thank you so much. Your insights to the problem statement has given us an extra edge to the participants. I truly believe that in order to develop an idea, in order to bring up great innovations to the table. We look forward to interact with you more. Thank you so much, dear mentors. And thank you so much to all the participants watching us now today live, and to all of them who would watch us in the future. All the very best. We look forward to your submissions. Have a great evening.